Okay, so a lot of you didn't have any challenges with this, but I'll solve it anyway, and then I'll try to be as quick as I possibly can so that we can look at part B too. Okay, so we have a condition here. We've been told that B must be greater than this. So if you get the negative and the positive, you can throw away the negative. You don't need it. Okay, so to solve for B here, you can simply integrate this. When you integrate this, you have 2. Remember, when you're integrating, the power of x will increase by 1, and then you divide by the new power, which is 1 plus 1. And then plus, for a constant, you just introduce an x, because it's like saying 5x to the power 0. So you just add the 1 there, which will make it an x here. So in short, you simply introduce an x when you're integrating a constant. So you are integrating from 0 to 5, and then we are told that the answer here is 14. So now let's simplify this. We have 2x, 1 plus 1 is 2 over 2 plus 5x from 0 to 5. So you can cancel those 2 out, so that you have b squared plus 5. What's wrong with my light? Okay, so what have I done? Okay, so with this, you have x squared plus 5x integrating from 0 to b. So, and everything is equal to 14, by the way. And then you can simply substitute the b's there. So b in there, this will be b squared. B there, this will be 5b minus 0 there and 0 here. We simply have a 0 is equal to 4. So now we have b squared plus 5b is equal to 14. So you can bring the 14 this side like this. And then the product, I want to use the factorization method. The product is negative 14, then the sum is 5. So the factors should be some 2 and the 7, but because this is negative and this is positive, this will be the negative one, since this plus this should give us that. Okay, so we have this one, and then minus, instead of writing 5b, you can write it as 5b plus 7b minus 14 is equal to 0. So now I can factor the b out here. So I have the b minus 2 plus 7 there, that's b there, minus 2. So that we have b plus 7, and then b minus 2 is equal to 0. So we can conclude that either b is equal to 2 or b is equal to negative 7. But because we have this condition here that b must be greater than 0, anything that is less than 0 will be rejected. So this one, not admissible, not acceptable, or not applicable. So this one has been rejected, and therefore our b is equal to 2. So part B is saying the diagram below shows the curve y is equal to x squared plus 4x plus 3 intersecting the x-axis at P and Q. This one and this. Find the coordinates of P and Q. This was easy too, since on the x-axis the y coordinates are 0. So the coordinates of P will be some x, comma 0, Then the coordinates of q, let's call it x1, will be x2 and some 0. So this must be bigger than this when deciding which point should be used. So we can say y is equal to 0 on the x-axis, so that where you have a y, you put a 0. So you have 0 squared plus 4x plus 3. Then when you solve for x, the product is 3. Then the sum is 4. And since the product is a prime number, we only have two factors, 1 and 3. So this times this is that, this plus this is this. Yeah. So we can have, let me just write this thing this side. Then instead of having a 4 there, we can have this. And then factor the x out, x plus 1. You factor the 3 out, you have x plus 1 again. Then this is equal to 0. Then you have x plus 3. And then you have x plus 1. And this is equal to 0. And therefore, x is either equal to -3 or x is equal to -1. So you expect -3 to be somewhere this side. Of course, you can't have a -3 there. And then this will be -1. So hence, the coordinates for P will be -3, 0, and the coordinates for Q will be -1, 0. So this solves the first part. And then the area of the shaded region. So to find the area of the shaded region, let me just, okay, I was fixing my light. So to find the area of the shaded region, since this one is below the x-axis, you expect it to be a negative unless you interchange the limits of integration. You swap the -3 and the 1. Yes, you have a positive. But for me, I would rather you just use the modular signs, and then you get the negative sign and change it to a positive number. And then you can find this one alone on its own, since it has different limits of integration. So let's do that. I'll start with this one here downstairs. Let's call it area 1. So area 1 will be the integral from a to b of f of x with respect to x. Yes, so since we're integrating from here to there and it's negative, you can introduce the modular signs and say from -3 to -1, and then you have the function here, which is x squared plus 4x plus 3 dx. And then you close. If you don't want to use these, you can just interchange these two. Put the -3 on top and this one at the bottom, because you expect your area to be negative. Okay, so now if we integrate that, we have x to the power 3 over 3. Remember, when integrating, you increase the power by 1. It is only when you are differentiating that you get the difference, which is subtraction. So for integration, you add the 1 and then you divide by the new power, plus 4x. So the power there was a 1, you add another 1, so this one will be a 2, and divide by 2. And then for a constant, simply add an x at the end, like this. And then you are integrating from here to there. So now to find the actual area, you can simply substitute the x values with, the x variables with these values here. So this is -1. Let me use square brackets. -1 cubed, and then everything over 3 plus 4, -1 squared over 2 plus 3, -1, and then you can put these things in brackets, or maybe let's just maintain the square brackets and say minus. So every time you have a minus, make sure that everything you write is in brackets. Once you leave the brackets out, then everything you are doing is not correct. Someone is coding. Okay, so where you have an x, you can do this, plus 4 -3 squared over 2. Actually, this should have been a 2. We should have simplified this area, but it's okay. And then you have this -1 to the power 3 is still -1. Then everything over 3. This one there is 2. -1 squared is 1 multiplied by 2. This would be a 2. Then minus 3. And then minus -3 to the power 3 is 27. -27 divided by 3, this would be -9. So a very common mistake here is to cross this like this, and then you square this and say you have +9 there. You don't do that. That's not correct. So you have to find this one first, or you can write it as this, and then everything over 3, and then you can cancel out like this, and then you have a -1 there. Then yes, this will work, but not cancelling like that. And then this is a 2. -3 squared is 9 multiplied by 2. This is 18. And then this and that, this is a 9. And then you have -1 over 3 minus 1 this side. Of course, don't leave the negative the modular signs, because the answer here will be a negative, as you can see. And then minus this minus this is 9 minus that's just a 0. And then -3 multiplied by this, or maybe we find the common denominator, which is a 3. When you subtract this, you have -4 over 3 like this. And then when you take the modulus of this, you have 4 over 3. So this negative was expected since the area is below the x-axis. So now to find the other area, you change the limits of integration. So you can say area 2 is equal to the integral from -1 to 0. Please don't get the y coordinates. You are integrating from here to there, because you are differentiating with respect to x. The limit should be from the x-axis. So you have -1 all the way to 0 of x squared plus 4x plus 3 dx. So you don't need the modular signs here, because this one is above the x-axis, so it is expected to be a positive area. So now this one will be, when you integrate, this will be x cubed over 3, and then this one will be 4x squared over 2, and this will be 3x. Remember, for a constant you just add an x. So you have this, and then this is a 2, of course. Let's simplify it. and then you can substitute the x coordinates. So this one will be that plus 2 plus 3 0 like this, and then minus with -1 you have -1 to the power 3 over 3 plus 2, where there is x you put -1 squared, then plus 3 -1, then you close the brackets. Everything here will be a 0. As you can see, these are all zeros, minus this -1 to the power 3 is still -1, then 2 times -1 squared, this is 2, since -1 squared is 1, and then minus 3, since 3 times -1 is that. So we have negative, of course this minus this is -1. So when you subtract these, you have a -4 over 3. Then negative times negative will be 4 over 3. So by the way, it's a coincidence that the two areas are the same. It's not always the case. So area 1 is 4 over 3. Then area 2 is also 4 over 3. So the total area will be this plus this. As you can see, to find the total area, you have to add this one to that. So this will be 4 over 3 plus 4 over 3. Then since the denominators are the same, this will be 8 over 3 units squared, like this, and you are done.